In this video, I'm going to talk about how to do calculations for the fourth part of the asteroid drop assessment, where you're looking at how gravitational and potential energy change as an object falls. So you have your table in the assignment, and when we look at the tennis ball, we can use the value for mass as 60 grams, the value for g, which is acceleration due to gravity, as 10 meters per second, and then our height varies. So initially, when I first drop my ball, our value for height is 1 meter. Our calculation for potential energy says that potential energy equals mass times acceleration due to gravity times height. So for this first point, my mass is 60, my acceleration due to gravity is 10, and my height is 1. So I just multiply across. 60 times 10 times 1 is 600. Now, at that top point, when I first drop the ball, I do not need to calculate kinetic energy. I know that initially it's not moving, so my kinetic energy must be 0. Now, throughout the whole time it's dropping, my total energy needs to remain the same. So since initially all my energy is potential, I know that 600 is also the total energy. So as I fill out the table, I just need to worry about my total energy being 600 when calculating kinetic energy. So when I fall a little bit further, the potential energy is now my mass is the same, 60. Acceleration due to gravity is 10. But later on, instead of it being 1 meter, we're looking at it at 0.9 meters. 60 times 10 is 600, times 9 is 540. So I remember my total is always 600, so kinetic energy would be whatever I need to add to 540 to equal 600. So you can either calculate that as doing 600 minus 540, or just think about it in your head, and kinetic energy would be 60. Right. Now I use my values for kinetic energy to find my speed. Initially, I just know that my speed, or v, is 0 meters per second. It's not moving when it initially falls. As it speeds up, I want to calculate. Now, you can solve this however you want, but I'm going to show you how I would do the steps. So when my kinetic energy is 60, to find my speed, I use my kinetic energy equation. This is kinetic energy equals 1/2 times the mass times speed squared. So my kinetic energy is 60 equals 1/2 times 60 grams for my mass times v squared. Now you could solve by multiplying 1/2 times 160 and getting 30, but I'm going to just start by dividing each side by 60. 60 divided by 60 is 1, so I get 1 equals 1/2 v squared. To get rid of 1/2, I multiply each side by 2, and I get 2 equals v squared. Then I want to take the square root of each side. This is something you might know some of these values off the top of your head, but you just plug it into a calculator, entering in 2, then clicking square root. So I take the square root of each side. The square root of v squared is v, my speed, and the square root of 2 is 1.4. So my value for speed is 1.4. When we go down even further, right, our kinetic energy is going to end up being 120. So if we wanted to calculate the speed for this, I still use kinetic energy is 1/2 mv squared, and I plug it in, so it'd be 120 equals 1/2 times 60, which is my mass, times v squared. Divide each side by 60. 120 divided by 60 is 2, equals 1/2 v squared. To get rid of the 1/2, I multiply each side by 2, and I get 4 equals v squared. Take the square root of each side. The square root of 4, which I can do in my calculator, but I might know, is 2 equals my next speed.